They built it to deliver the end of the world. Now it's rewriting its future. Born in the shadow of mushroom clouds and forged for missions no one dared to imagine, the B52 Stratofortress was a flying symbol of Cold War brinkmanship. It wasn't supposed to last, it wasn't supposed to matter by now. But in 2025, this 70-year-old war machine isn't just flying, it's transforming. And what's happening under its wings might just change aviation forever. If you want to see how a nuclear-era relic is becoming the blueprint for tomorrow's skies, hit that like button and subscribe. Because this isn't just an upgrade, it's a resurrection. When the B-52 first thundered into service in the 1950s, it was celebrated as the ultimate expression of American air power. 8 turbojet engines, 8 decades of unchallenged payload capacity, and an unblinking readiness to cross oceans on a single mission. Its peers, other bombers, fighters, and transports, were decommissioned, mothballed, or left to corrode in U-steel graveyards. But the B-52 kept flying. Why? Because no new design could match its blend of endurance, reliability, and sheer destructive potential. Now, instead of being retired, it's being reborn. Under those iconic swept wings, the B-52's original TF-33 engines, born in 1962, were gas-guzzling, maintenance-hungry relics. They belched smoke like rolling coal trucks, burned through fuel as if it were water, and relied on explosive cartridge starts that detonated miniature charges to ignite the turbines. Spare parts vanished decades ago, forcing crews to scavenge scrapyards or hand-machine critical components. Every takeoff risked compressor stalls or flameouts. Every mission risked leaving the crew stranded on a runway somewhere, waiting for miracle mechanics to cobble together an impossible repair. That unsustainable nightmare collided head-on with Pentagon mandates to keep the Stratofortress flying until at least 2050. Enter Rolls-Royce's audacious solution, the F130 engine. Not born of bombs and dogfights, but bred in the lap of luxury business jets. The F-130's DNA traces back to the BR-725, the powerhouse behind Gulfstream's record-setting G650. It wasn't just bolted onto the B-52, it was surgically grafted. Each F-130 spits out 17,000 pounds of thrust, a brutal 42% jump over the TF-33, and slashes fuel consumption by 40%. What once required a fleet of tanker support now demands far fewer mid-air refuels, stretching operational reach and cutting logistical tails. The new engines boast modular cores designed for predictable maintenance, real-time health monitoring, and AI-driven diagnostics that whisper warnings before a single blade falters. Imagine waking up the world's most iconic bomber with a software update rather than a roll of duct tape and antique wrenches. But grafting 21st century engines onto a 1950s airframe was no drop-in upgrade. It was a full-scale engineering reinvention. Rolls-Royce specialists had to reverse engineer structural interfaces recorded only in faded blueprints and oral histories. They scanned museum pieces, digitized decades-old stress analyses, and rebuilt pylons from the ground up using titanium alloys and carbon composites. Custom exhaust nozzles were crafted to manage heat signatures and minimize drag spirals that could cripple range. Even the nacelle geometry was fine-tuned with computational fluid dynamics to prevent turbulence pockets that would sap performance. Then came the digital divide. The F-130 runs on FADEC, Full Authority Digital Engine Control, an autonomous brain that optimizes thrust, fuel mix, and maintenance schedules in real time. The B-52's original flight systems, pure analog, wires, relays, switches, and mechanical gauges. To bridge these worlds, engineers created bespoke digital translators that convert FADEC outputs into signals the Stratofortress can interpret. It's like teaching a 1950s telephone switchboard to handle 5G calls, except the stakes are global deterrence and multi-billion-dollar defense budgets. This was not a garage-level hack. It was surgical aerospace alchemy. Every bolt, bracket, and bushing was assessed through digital twin simulations before a single prototype took to the sky. Stress tests at Stennis Space Center subjected twin F-130 pods to simulated altitude extremes, scorching heat, and bone-rattling vibration. At Arnold Engineering Development Complex, they recreated frigid mountain passes and desert mirages in climate chambers. Every failure spawned data, and every data point sharpened the redesign, ensuring that when the B-52J, as the upgraded model is now dubbed, finally breaks ground, it does so with the reliability of a modern airliner. The implications stretch far beyond the bomber community. The F-130's performance profile meets, and in some cases exceeds, civilian noise and emissions standards. Its compact footprint makes it a candidate for future regional airliners and corporate jets, promising airlines up to 40% fuel savings and maintenance costs half of today's benchmarks. What began as a last-ditch effort to save a Cold War icon may redefine how airlines, leasing firms, and OEMs think about propulsion. Why design from zero when you can reinvent the tried and tested? For the US defense establishment, this isn't just a platform upgrade, it's a strategic manifesto. Keeping the Stratofortress flying on cutting-edge engines sends a brutal message to rivals. Innovation isn't limited to startups and stealth fighters. Sometimes, the biggest game changer is resurrecting a legend. And for commercial aviation? It's a wake-up call that legacy platforms, once thought obsolete, can become incubators for tomorrow's breakthroughs. What started as a mechanical overhaul has become a global blueprint for modernization, military and civilian. Allies are already eyeballing retrofit programs for patrol planes, transports, and surveillance aircraft. Budget-crunched nations are realizing they can avoid decade-long procurement sagas and expensive new builds by upgrading what they already own. This re-engining doctrine could ripple through fleets worldwide, rewriting the calculus of fleet renewal, carbon goals, and air mobility strategy for decades to come. And it all began with a bomber nobody thought could still matter, a relic-turned-revolution powered by an engine that dared to dream bigger than war. When the first B-52J lifts off under F-130 power, it won't just symbolize survival, it will herald the new age of aviation, where innovation and heritage collide to forge the next frontier in flight. But before that future could take flight, the engine had to earn it. They didn't just build the F-130 and hope it would work, they punished it first. At Stennis Space Center, engineers mounted twin engines under custom pylons and fired them up in a gauntlet of ground tests. These weren't polite certification runs, these were brutality trials. How much vibration before casing integrity begins to fracture? How do the exhaust flows react at max throttle under stress torsion? Can the FADEC adapt when one engine is surged into an artificial stall? What emerged wasn't just green lights, it was data. And from that data came trust. Next came the real reckoning, altitude simulation. At the Arnold Engineering Development Complex, one of the most advanced test environments on Earth, the F-130 would face its high-altitude baptism. Inside hyper-controlled chambers, the engine would simulate cruising at 35,000 feet over Arctic deserts and tropical thermals. Thin air, high heat, rapid thermal cycling. These weren't just environmental stressors, they were tests of survivability. Any fault, no matter how small, would cascade. FADEC misfire, game over, turbine flutter at simulated altitude, redesign everything. Fuel atomization failure at low pressure, scrap the integration package. But the F-130 held, and that quiet success had global consequences. Because while the military was focused on bomber survival, someone else had been watching from the shadows, commercial aviation. On paper, the F-130 was a war engine. In reality, it was a civil aviation disruptor hiding in plain sight. Born from business jet architecture, the F-130 wasn't bloated with overbuilt wartime redundancies. It was light, nimble, and optimized for fuel efficiency. And unlike most military power plants, it already met civilian noise and emissions standards. That sent shockwaves through airline boardrooms. Why? Because modern carriers are desperate. Desperate to cut fuel bills. Desperate to squeeze more flight hours out of regional routes. desperate to find power plants that don't need 3 hours of inspection for every hour in the air. And here was the F-130, compact enough to fit on airframes far smaller than the B-52, quiet enough to operate out of city-adjacent runways, smart enough to run with predictive diagnostics that slash downtime. Some executives saw it as a curiosity. Others saw it as a Trojan horse, one that could break open the stagnating engine duopoly between General Electric and Pratt & Whitney. Because what began as a bomber's life support system was suddenly being whispered about in corridors at Embraer, Mitsubishi, and even Airbus. A war engine, powering low-cost carriers. It sounded absurd until the specs started circulating, but the B-52's transformation wasn't just about thrust and fuel efficiency. The aircraft itself was undergoing a parallel evolution. No longer the B-52H, the re-engined variant now carried a new designation, B-52J, and with it came more than a new nameplate. It came with a total redefinition of the airframe's mission. This wasn't just a bomber anymore, it was turning into a flying digital war platform. The heart of that change? A newly integrated AESA radar system, giving it unrivaled tracking capabilities, jamming resistance, and electronic warfare resilience. No more relying on external surveillance support. The B-52J could see, jam, coordinate, and strike all from one cockpit. New wiring harnesses snaked through the fuselage, hundreds of miles of fiber optic cabling designed to connect weapons systems, radar, avionics, and targeting pods into a single unified interface. The wings? Reinforced, not just to support the weight of the new engines, but to house next-generation munitions, hypersonic glide vehicles, stealth cruise missiles, and autonomous drone pods. And then came the backbone, a digital core linking the B-52J into the wider military mesh, real-time comms, network targeting, live threat mapping, shared between fighters, satellites, and surface fleets. What once lumbered across skies as a symbol of brute force power was now a floating node in the US digital battlespace. But even with all this momentum, the transformation wasn't without friction. Originally, the Air Force wanted the B-52J operational by 2030. That target has now quietly shifted to 2033. The reason? Complexity. Fitting modern digital systems into a mid-century airframe turned out to be less engineering and more archaeological excavation. Wiring channels were incompatible, load tolerances didn't match, and integrating digital engine controls with analog avionics triggered wave after wave of unexpected failure modes. But the solution wasn't guesswork, it was digital twins. Rolls-Royce and Boeing used virtual replicas of the entire aircraft, complete with airflow modeling, stress propagation, and real-time thermodynamic simulations to solve problems before they happened. Simulations revealed heat stress points near the new pylons, which led to reinforcement of adjacent wing spars. Simulations identified vibration resonance that would have burned out avionics after 400 flight hours. Simulations even predicted electromagnetic interference between the radar array and engine control systems, saving millions in redesigns. Every delay came with dividends. Every tweak added a layer of resilience. And what's emerging now isn't just an upgraded aircraft, it's a case study in how Cold War engineering meets AI age execution. While critics point to the schedule slips, insiders see something else. A blueprint for how legacy systems can be reborn with less risk, less cost, and more adaptability than any clean sheet design. The B-52J isn't just thriving, it's proving a model, a way forward for militaries, manufacturers, and airlines, all staring down the barrel of outdated fleets and impossible replacement timelines. And this is only the middle of the story, because while politicians argue over budgets and global powers battle for supremacy in the skies, something remarkable is taking place on American soil. Not in Silicon Valley, not on Wall Street, but in a factory complex deep in the industrial heart of Indianapolis. This is where the future of American air power is being forged, one engine at a time. Inside Rolls-Royce's largest US facility, the F-130 isn't just being assembled, it's being redefined. A staggering $600 million investment has transformed this plant into one of the most advanced aerospace production hubs in the Western Hemisphere. Robotic arms carve components with sub-millimeter precision. Engineers in cleanroom suits oversee combustion chambers glowing with the heat of tomorrow's missions. And in the testing bays, sonic booms, controlled infernos, simulations of war without ever leaving the ground. But this isn't just about machines, it's about people. Over 1,000 skilled workers, engineers, machinists, QA specialists, have been hired for this engine alone. Behind every titanium blade is a welder with decades of muscle memory. Behind every sensor is a software engineer writing algorithms for predictive maintenance. And behind every flawless run is an American workforce reminding the world that industrial excellence still lives here. The F-130 isn't just an engine for the B-52J. It's become a lifeline for small aerospace suppliers across the country. From carbon fiber specialists in Ohio to precision casting firms in Arizona, the retrofit program is quietly pumping oxygen into dozens of struggling US factories. What began as a Cold War relics revival has morphed into an economic shockwave. Defense isn't just about missiles, it's about manufacturing might. And the message to rivals is clear. America doesn't just build planes, it builds ecosystems. And now the world is watching. Military officials from NATO allies, Asian partners, and even neutral countries have begun touring US bases where early B-52Js are undergoing tests. But they're not just looking at the jet, they're looking at the model, the strategy. What if, instead of spending billions on new fleets, you could take your aging patrol aircraft, surveillance planes, or transport workhorses and give them 40 more years of relevance? For countries constrained by tight budgets, outdated factories, or political red tape, the retrofit revolution is more than appealing, it's transformative. By re-engineering instead of replacing, the US has proven that modernization doesn't have to mean ground-up design. It can mean smarter upgrades, faster rollouts, and a drastically lower price tag. Suddenly, the B-52J isn't just an aircraft. It's a prototype for an entire doctrine shift, one that nations from Brazil to Poland are now evaluating for their own fleets. And as the defense world shifts, so does the definition of military might. Gone are the days when emissions and fuel consumption were afterthoughts. In a world increasingly shaped by climate policy, resource scarcity, and public scrutiny, even war machines must answer to carbon calculators. Here's where it gets wild. The B-52J, powered by the F-130, actually reduces fuel burn by nearly 30%. That's fewer mid-air refuels, less tanker risk, and a lighter environmental footprint on every sortie. For a bomber built in the 1950s, that's nothing short of revolutionary. And it doesn't stop at emissions. Every time the US decides to retrofit rather than rebuild, it saves massive amounts of raw materials, aluminum, titanium, rare earths, not to mention the energy and carbon cost of new factory production. The result? A new category of aircraft, the green warfighter. Military modernization is no longer just about survivability, it's about sustainability. The Pentagon knows it, the EPA is watching, and quietly, so is the FAA. Because the most shocking ripple effect of this entire story isn't what's happening in defense, it's what's about to happen in civilian aviation. For decades, airlines have demanded cleaner, quieter, more fuel-efficient engines. And for decades, manufacturers have struggled to deliver. But now, Rolls-Royce is sitting on a gold mine of data. Years of simulations, stress tests, and real-world performance trials from one of the most extreme aircraft ever flown. That knowledge is already bleeding into commercial development. Engineers designing the next generation of narrow-body jets, the replacements for today's A320s and 737s, are drawing directly from F-130 research. Materials, fan configurations, predictive maintenance protocols, even noise suppression learned from military standards is now being retrofitted for civilian use. It's a feedback loop no one anticipated. In short, the B-52J isn't just an upgrade, it's a catalyst. A 70-year-old airframe is about to do something Boeing and Airbus couldn't. It might just crack the code for the future of affordable green long-range flight. And maybe that's the biggest twist of all. Because while the aviation world chases shiny prototypes and billion-dollar moonshots, the aircraft with the biggest impact on our future might just be the one no one expected to survive. A bomber from the Cold War, still flying, still fighting, and now leading the way. If this blew your mind like it did ours, hit that like button and subscribe, because what's coming next will change everything you thought you knew about flight.